So this is Stats Lesson 4, and it's on the line of best fit. And so these are sometimes called regression lines, like that's what this line is. It's a line of regression. It's a line of best fit. It kind of models the data. This data looks like it's positive. It has a positive direction, a positive slope. The purpose of this is, I just summarize in one word, the purpose is it's a prediction line. So we use the line of best fit to make a prediction. So what that means is, like, let's say that we, say that someone had like a cereal that had 30 calories, So we would expect that cereal, if I kind of follow it up to the line, to have about maybe 2 grams of sugar if you have about 30 calories. That's the expectation. It's the prediction. We're using X to predict Y. In fact, this equation there, when you take stats, they actually put a little symbol on this. I want to just mention this. So the little symbol they put on here is this. It means the predicted value for Y. So we usually use X to predict Y. In fact, we could have, if I wanted to say 30 was my X, that's calories, which are my X values. My sugars are my Y values. So I could have used 30 and plugged it into the formula there and got a more exact estimate. I guessed it was about 2, but you could actually have, just typed in the equation. So it'd be 0.0697 times 30 minus 0.335. Which is 1.76. So I guessed it around 2. It's really a better choice to be 1.7. And so that's what the line of prediction is used for, line of best fit. Okay, so the first problem here is not too bad. Basically says, how much sugar would you expect a cereal with 180 calories per serving to have? So again, 180 would be here. And you notice, once you notice, each one of these points are a real data value. What I mean by that is, like this data value means there are 240 calories for this particular cereal, and it has about 12-ish, grams of sugar in it. And so each one of these points are actual cereals. The line of best fit doesn't necessarily have any of those points on it, but it's kind of like an average. It's kind of like a predicting line that we use to make predictions. So 180 is not, there's no actual point, so we're going to use a prediction line here. So if you go up to the line and go over, you can see around 12-ish. I'm not sure exactly. I think about 12 would be a good answer. Again, if you want to do that more exactly, you could just use the calculator, and instead of plugging in 30 there, I would plug in 180 and 12.211. So again, we're just plugging a value for X. These are our X values, or our calories, and we're predicting the Y values. Try this one. This is kind of interesting. One cereal had 0 grams of sugar. So which one of those cereals? There's only one of them that actually has 0 grams of sugar per serving. So identify it. Like this one right here, that one, no, that has 5 grams. So 0 grams is this. So we're talking about this particular cereal. I don't know what the name of it is, but it's cereal right there that had 60 calories, but 0 sugar. So the calories must have been coming from something other than sugar. How much less sugar does it have than the line of best fit would predict? So, well, we know 60 calories is what we know. So if you go up to the line and then draw over, it looks like about 4-ish. So it looks like about 4. Again, we could use that equation and plug in 60. So 60 right here for X, and we will get a much better estimate there for Y. But again, we're using the X values to predict the Y value. I love this question. So which of the following best explains this number right here? So if you think about like what you know, like we know Y equals mx plus b, right? So typically you think of that being your slope. In fact, in the past, I think we've called this the slope. more recently, we might have called it the rate of change. I want you to think of this as a rate of how fast something is changing. And this is like your y-intercept of the equation, or I want you to think of it as your initial starting point, your initial start point in the graph. Okay, so look at these answers. Which one describes this relationship? So the rate of change, the slope. So, by the way, just like some of them you can just cross out. Like this one has 0 grams of sugar, so not all of them have at least 0.6797. That's just a terrible answer. A gram of sugar has exactly, or has 0.0697 calories. I don't know if that's true. I think some of these calories are coming from things other than sugars, because how did this one get 60 calories and have 0 sugar? So I don't think that's true. They're exactly, I don't love the way that's phrased. So it says exactly. Well, exactly, no statistician talks like that. We say, I'm 95% confident, we'll give yourself margin of error. We don't talk in those kinds of terms when you're a statistician. So I really don't like that, because, again, we're just using this line to predict. If you've ever made a prediction, it's not an exact science. We're not positive our prediction will be exactly right. We're just trying to make the best prediction we can based on data. And so I just don't think that's exactly true. Again, because 60 calories and 0 sugars doesn't make sense there. This answer makes a lot of sense. I love the way it's phrased. On average, we estimate, so that's a statistician word, we estimate the amount of sugar will be increased by that for every additional calorie per serving. If you think about slope or rate of change, that's change in y divided by change in x, right? Well, what is y called here? So y is our sugars. So change in sugar divided by change in calories is our x. So calories. And this slope is this number. If I were to write that number as a number, I would write 0.0697 divided by 1. And that puts everything in perspective. So sugar is increased by 0.0697. Calories increase for every additional 1 calorie per serving. So that makes a lot of sense. It's interpreting the slope of the problem, basically, saying what it is. Try these 3. 1 serving of cupcakes has 15 grams of sugar. Which one is that? Sweet cup and cake. So where is that? 15 grams of sugar. So that's the only one. That must be sweet cup and cakes right there. Okay, about how many grams of sugar does the line of best fit? So if you normally have 15, we would have expected, I don't know, 220-ish. Chunky Bark cereal, great name for a cereal, contains 140. So 140 is right about here. So 140 is here. That looks like to be this one. About how many grams of sugar does the line? So if we go up to the line of prediction here and go over, looks like something slightly less than 10, maybe 9. If we got to get it more accurately, we could take the 140, plug it in for x, and we get that exactly. Or the prediction would be a better prediction, I guess. And this one, chocolate frosted sugar bombs, has 300 calories. Oh, that's off the page. Like I can't even see that. That's so far. So it has 300 calories. So I'm going to plug that in for x, and you would just at that point type in 300 there instead of 180. So I'm going to copy and paste, change that to, and we got 20.5 or so. Okay, you might have know this about correlation, but you can tell this one has a positive slope, so a positive correlation to this line. So this line right here, this line of best fit, has a positive slope. So what that means is as x is increasing, the y value is increasing. So as x increases, so does y. This one seems to, in contrast, have more of a negative correlation, because the slope is negative of that line. As x increases, the y value is actually getting smaller. So y is decreasing, or vice versa. So that's negative and positive correlation. This was definitely a positive correlation, and we would add one more thing besides just saying positive. We would say it's pretty strong. So the points are tightly wound to that line. It's a very good predictor, so it's a strong correlation. This one's clearly positive, but this one, you might say weak, or you might say like moderately strong, certainly not strong. So sometimes we use words like weak or moderately strong to say it's not quite as strong as it could be. So that the scatter is a little bit more, but it still has a pattern. It still is definitely increasing. This one, some graphs just have no correlation. So it's not positive or negative. If you think about a line, a best fit that would be not positive or negative, it would have a slope of 0. The line would be here, but this would not be used for prediction purposes because it really doesn't predict anything. We have no idea if the y value is going to be very high or very low there. This one, clearly negative, so the positives are out. It's a judgment call, but it looks pretty strong to me, so it's strong negative, I think. This one is saying if price of stock A drops, what will happen to stock B? Will it increase or decrease? So this is one that has a negative correlation. So which means as X is increasing, Y is decreasing, or vice versa. They're going in the opposite direction because it's negative. So if price A drops, price B will increase. So stock B will increase. So what that means is like stock A has dropped. So that means like this is a very low value for stock A, but it's very high value for stock B. They tend to be going in different directions there. According to Best Fit, your average expenditure of cell phone service was estimated to be 300. So 300 is right about here. So I go over the line of Best Fit and go down. That's about 2002-ish. Some of these answers are just wrong. Like that's not measured. CPI is not measured in dollars. It says it's the ratio of current price to the price in 1980. It does seem like right away I'm leaning towards A. I think that's right, but I like to look at all of them sometimes on these just to be sure. CPI 1981 was 100% greater. 81 was about here. Now it's just barely greater. I don't think that's it. CPI has grown about 100% since 1980. So it was 1 in 1980, which you would expect then in 2010 to be twice as much, which would be 2. It's more than twice as much. It's not that. It's got to be A. Use the line of Best Fit. What is the price of how many fish a bear can eat? 22 miles in one day. So I don't know, that's somewhere out here. So it's somewhere up there, but I need to do a better job of estimating this. So I'm going to plug into the formula and see what happens here. So let's get our calculator out. So this would be 0.5 times 22 plus 13. 24. So 24 is right. And last one, 80 beats per minute. So that's this one. So that's talking about this runner right here. Where would you have predicted? So if you go over to the line of prediction from 80, you go down, I don't know, 30, what is that? 4.5 is about that number compared to what this one is 36. So what's the difference? I think I asked for the difference. How many more minutes? 34.5 and 36 is 1.5 minutes difference. This is a good one. If you have a problem like this, just draw the line of Best Fit. I didn't like that, but let me see if I can do a slightly better job. Okay, so if you do a problem like this, you want to kind of identify a couple points and write down the order of pairs. Like I see this point right here is 12, 30. I don't know, maybe this point right here, 72, 8-ish. So we're finding this slope, basically. We want to figure out which one of those is the right slope. So if you do slope, it'd be 30 minus 8. That's change in y values. Divided by change in x values would be 12 minus 72. So you get about 22 divided by negative 60. Let's get our calculator out for that. 22 divided by negative 60. Put a decimal point in there if you want a decimal. Negative 0.36. So that's negative, this should be a slope, 0.36. It's closest to probably this one, negative 0.4, so I think I would choose that one. Let's look what the y-intercept looks like. I thought it was about 35-ish. 36 looks about right. I think that looks good there. So you could use the slope or the y-intercept. It's really helpful to be able to find the slope. Again, this formula there is y2 minus y1 over x2 minus x1. That's your slope formula if you didn't know it. And last one, let's look at this data here. So we're going to put in both lists of data. And so I'm going to call this college, or COLL. The second list I'm going to call INC income. Okay, I'm going to put in 0, 1, 2, 4, 6, 8, 10. And 4, 7, 36, 38, 32, 41, 184, 57, 252, 68, 952, 82, 732, 85, 228. And I'm going to go to data statistics page here. So this one, choose my X variable, which is years of college. We're going to see if that predicts how much income I'll make. So income is here. Well, it looks like, according to this chart, the more you go to college, I'm thinking doctors, lawyers, they go to college for a long time, they make more money. That might be part of it here. So those kinds of things. So analyze and regression, and you want to do linear regression, and it does a regression for you. So it gives you the equation of this line. It's y equals 5592. I'm just going to round it off. Plus 33607. And that's for our y value is our income, and our x value is our years of college. And we can use that to make predictions. So if you go to school for 3 years, which is not on the chart, you say plug in 3, and you can figure out about how much you make of yearly income according to the prediction tool that we have based on this data, which may or not be accurate. I don't know. For your area of the country, it really depends on area of the country as well, probably. So there'd be a lot more factors than this chart probably gives us. But that's how you do regression on your calculator. So